Hi folks, welcome back to Physics with Captain Rod, making this video here to help you out with number 17 in your unit, what is it, I guess 6 homework. So let's see, assume an electron in the first state absorbs a photon with the energy given. How much energy will the electron leave with? So just some reminders here. So you've got the nucleus, and then the electrons live in these regions called shells. I'm going to do this in green. So I'm going to say here's the first shell, n equals 1. Or that's in other words the ground state. And then here's the second shell. And that's all I'm going to draw, but there are more of them. Okay. And then the energy of an electron in any shell can be calculated by minus 13.6 EVs over n squared, right? That's not something I would expect you to memorize. You can, I'm going to be letting you use a page of notes for your final exam, so you can write that on there. So in the first state, all right, that means n equals 1. So I would put like E1. Right? And if you put a 1 here, you just get minus 13.6 EVs, or minus 13.6 electron volts. And what that means is that it takes 13.6 electron volts to get the electron to leave. Now, if the electron here absorbs 13.7 EVs in the form of a photon, there's enough energy to leave with a tiny little bit left over. How much is left over? 0.7. So the electron is going to leave now, and it's going to have an energy equal to I'm sorry, did I say 0.7? I meant 0.1 EVs, or 0.1 electron volts. And the electron is moving, all right? This is going to be a kinetic energy. Now, kinetic energy, remember how it's calculated, 1/2 mv squared. But, all right, there's kind of a unit issue here. You can't really equate this yet to this, right? Because this is a number in joules, and this is in electron volts. So what you need to do is take the 0.1 electron volts, and we're going to convert it to joules. And the conversion factor is 1.6 times 10 to the minus 19th joules per 1 EV. All right. Now, you're going to get a number. In fact, in this problem, that number is going to be 1.6 times 10 to the minus 20th joules. Now, you can equate that to the kinetic energy, because that's what that energy is going to be. So 1/2 mv squared, and for the m, use the mass of an electron, 9.11 times 10 to the minus 31st kilograms, and then solve this for v. Right, and that's going to be the speed of the electron. Right? Part B, you do the same thing. Okay? The electron in the ground state here, this guy, absorbs 20 EVs of energy. But it takes 13.6 to remove it. That's going to be used, if you will, to remove the electron. The difference between the two, in this case 6.4, I believe, is going to be a kinetic energy. The electron will leave with 6.4 EVs, convert to joules, take that number, set it equal to 1/2 mv squared. That will tell you how fast the electron's leaving. And again, repeat for 30. So that should be enough. That'll get you through 17. So hope that this helps. Have a great day.